Hi, my name is DJ Pong. I'm here to present my paper pertaining to development of machine learning model for prediction of IT project cost and duration. So let's begin with some backgrounds of the research project. Apparently, globally, IT industry is very promising. From $4.6 trillion in 2018, we're anticipating this will grow to $5.8 trillion by 2023. We're anticipating the growing rate is about 3.7 to 5.7% globally. That's the same trend. We are anticipating the IT project will grow at a similar rate like digital economy. I'm sadly to say that out of 20-30% projects considered fail, and 30-60% partially fail, and the success rate is about still remaining about 30% in average. So if you look at the chaos report on the bottom right from 1994 to 2015, this trend doesn't seem to change a lot. And the other interesting finding is on the bottom left table, whereby there's a success rate has a dependency on the size. The bigger the size, looks like the success rate is much lower compared to the smaller one. So we actually conducted so-called quantity survey. This quantity survey basically we want to list out 11 risk factors and targeting Malaysia Singapore project managers, project practitioners to give us a feedback how we can rank all these 11 risk factors. The risk factor actually was ranked on given in the bottom right corner, and we collected 115 responses, out of which two are biased, so we actually taken delete them, and the remaining 113 valid response. 60% more than 10 years project management experience, 79% of the respondents more than 5 years, 92 is IT project PMs, and 8% are non-IT. All right. So that's how pretty much on the respondent profile. Actually, what we did next step is to put all these risk factor, the what we collected, and rank and put them into so-called classifications using the risk matrix that graphically represented on the top right corner. So those under red means there's a high risk. Any risk exposure rating more than 18 is considered high, and the medium more than 10, and any lower than 10 are considered low. All right. So I'm glad to say that the 10 that we 11 that we positioned, the 11 risk factor, out of which 9 are considered high, rated by the respondent, and 2 are medium. And the top 3 are actually identified as R2, R5, R9. R2 stands for underestimated cost and time, followed by poor requirement management, and R9 communication deficiency among stakeholder. R2 is a top rank, so I think what we're going to do in this project is basically using machine model to address underestimated cost and time. So that means we can give in a much better prediction in cost and time that will help to increase the project success rate. So there are 14 ML model was developed in this research using Python. Actually all these 14 models are listed on the top left. Deep neural network DNN, decision tree regressor. This is a global, what I call it, gradient boosting regressor, a hybrid GBR and DNN, K-neighbor regressor, long short-term memory, multiple linear regression, hybrid with DNN. This is a standalone MLR. PSO DNN stands for particle swarm optimization with the DNN. Random forest regressor, random forest hybrid with the DNN. SVR, support vector. SGB, SG boosting, SG boosting hybrid DNN. And we actually put it, this is test by 3 separate datasets. 2 are public available, and 1 is a private owned, which is a EVP. We are going through by the evaluation go through by 6 different performance criteria. These are the mean square error, RMSE, MSLE, root mean square log error, mean absolute error, MAE, mean magnitude of relative error, MMRE, median magnitude of relative error, MDMRE, and percentage of percentage, PRED, bracket M. And the experiment actually go through by 3 different steps. Firstly, we also had to split the data set into the ratio of 70-30% as a guiding principle for training and testing purposes. So the first step is go through the training steps. So whatever the model we developed, we had to pass through the training. Then the second step is testing, which means that the remaining 30% of test data set will be used for that purpose. For evaluations, let's say after evaluation you find that we require some fine-tuning on the hyperparameters, then we go through the hyperparameter training. This will go into the loop until the optimized results is delivered. So the top model will put forward for the live actual project verifications. So what does it mean in the before we go to the detail of how live verifications? Let's go through dataset overview. The first dataset is a disharnessed dataset. This after the researcher called disharnessed, a Canadian. This dataset is very small, it's 81 records, of which 9 attributes are inside the records and 8 feature and 1 target. The second dataset is a public available. It's called an energy building dataset, or short we call it ENB. 768 records, of which 8 features and 2 target, total 10 attributes. And the last is a privately owned, we call it unvalued plus dataset. It's very much a combination of EVM, unvalued management dataset, plus the 2 other attributes that are introduced in the research. So there are 12 attributes in overall, 10 are feature and 2 are targets. Total instances are 8,470 records. So the one on the right is here is a table to show how the discrete statistics for each of the data sets. So let's go through the test results. All right, the test results indicated for disharnessed data sets. MRRDNN is the winner for out of 14. The worst is DTR, stand for decision tree regressor. Okay, and the results I think indicated on the table on the actually illustrated on the left. And the red circle is just to highlight who are the winner of the evaluations. For ENB, not surprisingly, again, MLDNN is a winner, but somehow the worst model actually shifted from DTR to PSODNN. For EEP dataset test results, again, the VMLRDNN. So the reason why I go through 3 different datasets just to roll out the possibility of the dataset quality that can bias the evaluations, and so obviously the result indicated MLDNN works beautifully for all the 3 different datasets, and somehow for this EVP datasets again the worst model is PSODNN. So the test results overall, we can say that we can conclude that MLDNN is the most effective ML model for all 3 datasets. PSODNN is the poorest for ENB and EVP, and DTR is the poorest for the disharnessed datasets. So I started introducing using a different way of looking at the search result by looking at IVR, IQR, stands for interquartile range, statistical numbers. So the narrower the IQR means that the error is much more stable and consistent. So not surprisingly, for the MLDNN, the IQR is very small. It's 0.01 in comparison to the rest of the 14 model, right across the line. So the next step is we put this into live verifications by picking one of the projects, waterfall projects, conventional methodology. These are multi-tens of million dollars projects. A telco in the regions, South Asia regions, they're upgrading their PSSOS system overall to cater for demand. It's a multi-year project with I think close to about 100 resources involved in these projects. So the finding here, actually we collected 2 sample points, one at 43% and 53% completion point respectively. And this point we try to project what are the what is the anticipated cost needed to complete the project, so how long the duration we're going to take. So the ML predictions for at the 43% point is 0.8 and 0.65, and for 53% is 0.74 and 65, and the actual is 0.7 and 0.67. So how we rate this is EAC stands for estimate at completion, which is the total cost required at the end of the day. The actual fact is that 30% saving in the cost. EDAC stands for estimate the duration of completion. So somehow the actual results show that there's 33% faster than what we planned for. What the machine learning predictions was 0.65, which is very close to 0.67. And for the cost, there's slight variations depending where you are. So the closer towards the end of the project looks like the much closer to the actual value. There's one of the trend that we can see from the results. So MRA overall for the cost part is 0.009 and 0.03 for the EDAC. So if you translate to layman term, means there's a 91% accuracy for the cost predictions and 97% for the iterations. So the conclusion we're going to make here for this research is firstly, if you're comparing to the Ergil and his team in 2019 paper, reported that the EVM had accuracy in 82.6% for the cost and 42% for 43% for the durations. And what we did is in our results shows that we actually improved significantly over typically for the durations, 54.1% improvement in comparison to his study, 8.4% improvement in comparison to the cost predictions. Right, this align again with the Fansahari study. So cost is always more accurate than the duration prediction if you're using EVM. So overall, we can conclude that ML model is overcome the conventional tool weaknesses and improve the forecast accuracy significantly. All right, these are some of the findings that for different type of project conventional tools that we use. WBS breakdown structure, and we'll use the relative affirmative estimations or even analog-based estimations. So it's outperformed for all these numbers. All right, we are looking at a cost of 93% and durations of 97%. So it's much higher than what the current conventional tool can do. And with that, so I conclude that both predicted EVM and ED's accuracy were significantly enhanced in comparison to existing PM techniques and tools, and with a variance between the 5%. So I think that conclude my presentation today, and thank you for watching. Thank you.